Okay, so this lesson is on angles and arcs. Our goal for today, I can find angles and arcs of a circle. So first off, we're going to get our first vocabulary word for this section out of the way, and that is a central angle. A central angle. Now I'd like for you to see the word center in there, okay? And a central angle is an angle whose vertex is at the center, right? So this angle right here, if you look at it, I'll highlight it in blue. This is a central angle. All right, our next vocabulary word is arc. An arc, it's not arch, it's arc, is an unbroken part of the circle consisting of 2 points called endpoints and all the points in between them. So if I have a point here and I have a point here, this piece right here, which I'm like scribbling on, this is an arc, okay? This big piece right here is also an arc, but for these purposes, I just want to make sure you see that it's the curved piece is the arc. Okay, let's move on to the next part here. All right, so the next part tells us some facts about a central angle, and it's intercepted arc, okay? So a central angle has the same measure as its intercepted arc, okay? So this angle right here that I just traced in red is 98 degrees, and this arc in between these two endpoints then is also 98 degrees. So a central angle has the same measure as its arc, okay? Same thing goes vice versa. If you notice, this is a central angle because the vertex is at the center. So if the intercepted arc is 105, then the angle is also 105. Okay? All right. We have 3 types of arcs that we have to talk about. The first one is a semicircle. A semicircle is a type of arc, and it is an arc that is exactly 180 degrees, okay? So we're not looking at it as half a circle, meaning like this is a semicircle. That's not what we're talking about here. We're talking about this right here, or this right here is a semicircle from A to C, but I'm going to go in this direction. Okay, so this right here is a semicircle. And when you name the semicircle, you're going to use the endpoints on the end, AC, and then you're going to put 1 point in between, so ABC. That is our semicircle. Now, semicircles are named with 3 points, and so are major arcs. So let's do a major arc, or let's do the minor arc next. A minor arc is an arc that is less than 180 degrees. So I just need to find an arc that's less than 180. I can do arc AB, or I can do arc BC. So I'm just going to do arc AB. There's more than one minor arc drawn though. So this right here, arc AB, that is a minor arc. I could have also done arc BC. Last but not least, we have a major arc. A major arc is an arc that is more than 180 degrees. Okay. So if I'm looking for an arc not equal to, but greater than 180 degrees, I can start at A and I can get all the way to B. But if I go in this direction, then it's going to be a minor arc. So I can go in the other direction. So I'll go from A through C all the way to B. So ACB is a major arc. Notice for minor arcs, they may be used, minor arcs may be named by 2 points with a curve over the top, okay? That's a minor arc right here. But major arcs and semicircles must be named using 3 points, okay? So the 2 endpoints, and then a point in between those two endpoints. Okay, so example 1, it says use the circle given, find the central angles, all the central angles, and all the minor arcs, okay? All right, so what I like to do is I say that I attack the circle. I just get everything in there, okay? So I'm going to start by saying an arc or an angle that I do know, okay? So this right here is a central angle, and I know it intercepts this arc, so I know it has to be the same. So if that angle is 98 degrees, this arc is 98 degrees. So I'll start with that, okay? Same idea. I know this arc right here is 52 degrees because the central angle is 52 degrees. All right, now this arc right here, I would need to know what this angle is, and I can figure it out. How can I figure it out? So anything remaining, you're going to use a few things to help you. You're going to use diameters. Diameters give us a semicircle. And if we have a semicircle, we know it's 180. And then we can also use vertical angles. We know vertical angles are congruent. So I right away see a vertical angle. If you can trace something and it's an X, I'll do that right now so you can see it. Like so. This angle and this angle are vertical angles. So I know that angle is also 98 degrees. And if that angle is 98 degrees, this arc is 98 degrees. All right, now I'm going to use my diameter and semicircle for help. So here's a diameter. That means this is a semicircle and it's 180 degrees. So if you look at it, I already know that this much and this much, but I just need this right here. So what I'm going to do is I'm going to do 98 plus 52 and do 180 minus that. 98 plus 52. 0, carry the 1, that's 150. And then 180 minus that, and I get 30 degrees. So that arc and that angle is 30 degrees. 30 degrees, 30 degrees. All right, now I have one angle left. Whenever you have one angle left, it's always possible to find it, okay? You can use one of two facts. You can use that all of the arcs have to add to 360, or you can use a semicircle. So I see a diameter right here, therefore I see a semicircle. So here's a semicircle right here. I have this part, which is 98, so I just have to do 180 minus 98. 180 minus 98, and that is 82 degrees. So this angle is 82 degrees, and this arc is 82 degrees. And now I have every angle and every arc. The way I did it, is it the only way to do it? No, but those are the only correct answers. Okay, why don't you try pausing the video and trying this one on your own to see if you can get all of the angles and arcs. All right, let's see how you did. So you should have gotten this arc is 60 and this arc is 25. I see a semicircle right here, so these three angles have to add up to 180. So I'm going to figure out what this missing arc is right here, or this missing angle is right here. So I'm going to do 60 plus 25, which is 85, and then 180 minus that, which is 95. So now I know that this angle and arc are 95 degrees. Okay, next I'm going to get this angle. I can see here that I see an X, like that, right? So that means that 25 degree angle and that angle that I put a question mark in that looks like a 7 now, they are congruent. So this angle and this angle are congruent, so they're both 25. So that means this arc is also 25. All right, I have one last angle to find, which is always possible. So I can either use the semicircle and do 180 minus 25, or I can add up all the angles that I can add up all the arcs that I do have and do 360 minus that. I'm going to do the 180 minus 25. So I get 155, and that means this angle is also 155. And that's it for that one. Okay, so we've talked about central angles, and everything that we've worked with so far has been a central angle. And if you look at them, the vertex is at the center, right? Here's the center, the center, the center, and they have the same measure as their arc, okay? Now we're going to talk about inscribed angles. Inscribed angles do not have the vertex at the center, okay? So an inscribed angle is an angle whose vertex is on the circle and whose sides contain chords, which is spelled wrong, there's an H supposed to be right there, of the circle. So what we're going to do is we're going to draw circle P with inscribed angle ABC. So first off, let's draw a circle. Draw it right in here. Here's my circle. Okay. All right, we are now going to draw inscribed angle ABC. Okay, so you're going to need A, and then B is not at the center like it would be for a central angle. B is on the circle somewhere, and then C is also on the circle. So then I'm going to write that down. Write down A, B, C. And now I'm just going to make the angle A, B, C. So angle ABC here is an inscribed angle. The only thing that I'm missing is it says it's called circle P, and I did not put the center in and name it P, so I can do that now. There's circle P, and there is an inscribed angle, angle ABC. Okay? Now, I've already used this, but an intercepted arc consists of endpoints that lie on the sides of the inscribed angle and all the points of the circle between them. So if I highlight my angle right here, okay, here's my angle A, B, C. The endpoints are A and C, right? So the arc, the inscribed arc, is the arc in between those two endpoints. So my intercepted arc, not inscribed arc, sorry, my intercepted arc is arc AC. Okay, so we already know that central angles have the same measure as their arcs, but what about inscribed angles? They can't have the same measure as their arcs because they're not central angles, right? So what we know about inscribed angles is that the angles are half the measure of the arc. So if this angle, if I'm looking at this angle right here, angle ABC, it's called angle ABC in all three of these, angle ABC, angle ABC. The measure of angle ABC is equal to, I forgot the C, ABC is equal to half the measure of the arc. So the intercepted arc is AC. The intercepted arc is AC. The intercepted arc is AC here. So half the measure of AC. Okay, so I want you to realize, I'm going to give a quick example right here. I'll give two examples. Let me draw an inscribed angle. Here's an inscribed angle. Okay. And then I'm going to copy and paste this. Copy, paste. Okay. So if you look at this angle right here, which I will highlight in yellow, it's an inscribed angle because its vertex is on the circle. It's half the measure of its intercepted arc. So if I told you this arc was 80 degrees, what would this angle be? It would be 40 degrees, half the measure, okay? But what if I told you that this angle was 50 degrees? What would the measure of the arc be? It'd be double that, 100 degrees, okay? So if you look, the angle is still half the arc. The angle is still half the arc. Please just don't think always, oh, I take half. If I give you the angle, you have to double it to get the arc. Okay, let's do a couple examples with a little bit of complicated diagrams to make sure we're okay. If I gave you the straightforward, easy ones like this, it's too easy, right? Okay, so the first one here says find the measure of angle PRU. So the first thing I'm going to do is trace angle PRU to make sure everyone sees what it is with the highlighter. So PRU. Okay, so I want that angle right there. This one right here. What's PRU? It is an inscribed angle. That means it's half the measure of the intercepted arc. The intercepted arc is 118. So all I have to do is take half of 118. Okay? Half of 118 is 59 degrees. So PRU is 59 degrees. All right, now I want to find the measure of arc SP. So I'm going to erase what I have drawn on here because I'm going to use a different problem now. And now I need to find SP. So arc SP is this arc right here. So if I follow along, I'll use green here, and I take this endpoint and this endpoint and follow it until I get an angle right here. This angle is 27 degrees. So it is an inscribed angle. It is half the measure of its intercepted arc. I'm not going to take half of 27. I'm going to double 27. I'm going to do 27 times 2. So that gives me 54 degrees. So this is 54 degrees, and then you can see the angle is half the measure of the arc. All right, let's try another one. This is find the measure of arc ADC. Please realize that this should be a major arc because it has 3 letters in it. So I'm going to go A to D and then to C, which is all the way over to there. Okay. I need that arc. So if I have an inscribed angle, then I know that arc. So I want an angle that starts at A, ends at C, has endpoints of A and C. And if you look, this angle right here has endpoints of A and C, and it is an inscribed angle. It's 135. It's half the measure of the intercepted arc. So I need to double the angle to get the arc. 2 times 135 is 270 degrees. So the arc is 270, the angle is 135. All right, now I'm going to find angle DAE. So DAE. It's an inscribed angle. It intercepts arc DE. So if arc DE is 76 degrees, if I take half of 76, I get 38 degrees. So angle DAE is 38 degrees. So notice sometimes I take half, sometimes I double, and it's not just like, oh, when do you do it? When do you take half? When do you double? Depends on what you're given. The angle is half the arc. So if you're given the arc and you need the angle, take half. If you're given the angle and you need the arc, you double it. Okay, so this is right here. We have some practice involving this. Find the measure of as many arcs and angles that you can. Okay, so I'm going to try to start with anything that I know. Okay, and I think in class I did like A, B, C. Yes, I did. D, E, F, G, H. And then I started asking people, okay? And I was like, what can you find? And on this particular one, you can find all of those. You can find all of them. So I'm not going to like put A equals B equals C equals. I'm just going to erase them as they go, okay? So first off, I see that A is a semicircle, right? If you look at A right here, it's a semicircle. So I'm going to get A and I'll get B because this is a straight line right here. So that's also 180. So I'm going to erase A and B and put 180 there and 180 there. 180 there and 180 there. That was nice, right? Okay. The next one I noticed that I can get is I see a central angle right here. Remember, central angles have the same measure as their arc. So I know angle G. I'm not taking half. It's not an inscribed angle. It's the exact same. So this is 51 degrees. Okay, what can I do next? There's a couple things I can do next. I can do H right now. It's the only arc that's missing. If you look, I have this. I have this. I have this. The only thing that's missing is H. So I could add those 3 arcs and do 360 minus that if I would like to. Okay? I'm going to do that. Why not? I noticed it right away. I might as well do that. So I'm going to do... Or I can do 180 minus 73 minus 51. Either one's fine. I'm going to do 51 plus 180 plus 73. And then I'll take 360 and subtract that. So 51 plus 180 plus 73. So that's 180. I should get a calculator so I don't mess this up. I'll do it like this. 51 plus 73 is 4. And that is 124, and then 180 plus that is 304. Okay, so then 360 minus 304 is 56 degrees. You could just use a calculator, but I don't have one handy. I can get one handy in case I need it again. I'm going to. Okay, now it's handy. All right, so now I know that is 56 degrees. So I'm going to erase this, put 56 degrees right here. All right, so now I need either angle D, angle C, angle E, angle F. I'm going to get angle D next because I think it's one of the easier ones because it's a central angle. So if I follow angle D right here, it's a central angle. That means it has the same measure as its intercepted arc. This is its intercepted arc. So what I'm going to have to do is I'm going to have to add 73 and 56. Okay? 73 plus 56. Let me get rid of that. 73 plus 56. That's 9. And then 2, 1. 129. So now I know angle D is 129. And if you're like, wait, there was an easier way of getting that. You know that this is a straight angle. This is a linear pair. You could have done 180 minus 51. That's also 129. Sure could have. 129. Okay, so now I have to try to get C, E, and F. Okay, if you look at C, E, and F, they're all inscribed angles. Their vertex is on this circle, right? So I have to see what I can find, how I can find it, okay? So I'm going to start with angle C. I'm going to trace it, okay? If you look, that's an inscribed angle. I need to know its intercepted arc. So its intercepted arc is that 51 and 56. So I'm going to do 51 plus 56, which is 107. And then I'm going to take half of 107. So I'm going to do 51 plus 56, and then I'm going to take half of it. So half of 107 is 53.5 degrees. So now I know angle C is 53.5 degrees. I'm going to erase that, put 53.5 degrees. Okay, now I'm going to move to angle E. All right, I'm going to trace it and with a highlighter. Here's angle E. It's on the circle, right? So here's its intercepted arc. Ready? It goes from there all the way to there. So its intercepted arc is 180 plus 51. But since it's an inscribed angle, which is on the circle, the vertex is on the circle, I'm going to take half of that. So I'm going to do 180 plus 51, and then take half of that. So you can either hit divided by 2 or times a half. And you get 65.5 degrees. So now I know angle E is 65.5 degrees. All right, last but not least, I have angle F. Now, if you look at angle F, it is an inscribed angle because its vertex is on the circle, but this is not extended here, right? So, and I don't know how much just this part is. So I can't do it the same way I was doing the other ones, but, okay, if you notice right here, I'm going to highlight this instead. You have this quadrilateral right here. We know that triangles always add to 180. Quadrilaterals always add to 360. So I can figure out what angle F is by adding the other 3 angles in the quadrilateral and then doing 360 minus that. So I'm going to do 360 minus, and then I'm going to add up the other 3 angles. 53.5 plus 65.5 plus 129. So I'll first add 53.5 plus 65.5 plus 129. That gives me 247. So I'm going to do 360 minus 247. 360 minus 247 is 113 degrees. So angle F is 113 degrees. And now I have them all. Okay? All right. So I feel like I added 180 plus 51 wrong. I did. So I'm going to mess that up. So let me fix this. This is not 113 because this is not, or maybe it is. Hold on. 180 plus 51 is 231. I said it's, and then divided by 2. That's not right. That's why. Okay, so I need to fix my 65.5. I looked at it and it didn't make sense. It didn't look great to me. So I need to fix this right here. My work is right. My answer is wrong. That was 150. 115.5. I didn't use a calculator for that, or I did and I messed up typing it. So I have to do 180 plus 51 and then divide that by 2 or take half of it. And it's 115.5. So this was 115.5, my bad. So let me fix this 65.5 to 115.5. Then I can do 53.5 plus 115.5 plus 129, which is 298, and then 360 minus that, which is 62. That felt better. Okay, so there are all my angles. I don't know how I caught my mistake, but I caught it. All right, so here's another one. Let's try this one. Find the measure of as many arcs and angles as you can. They're like little puzzles, okay? What I'll do once again is I'll call this arc A, and I'll do B here, and then I'll do C, D, E. Okay, and you just gotta start somewhere, right? So even if you don't know where to start saying like, can I find this arc right here? There's an inscribed angle. Nope, there isn't one, so I can't do that. There's no central angle, so I can't do A first. Can I do B first? And I say, okay, I can follow this way, but then it doesn't come that way. So nope, I can't do B second, or I can't do B first. I'm going to have to either do C, D, or E first, okay? So I'm going to say to myself, or I'm not going to say to myself, but I'm going to say, do I see any angles that I do know? Do I see any semicircles? Is there anything that I can get from this, okay? So here's what I notice is that this angle is 72. You got to keep trying something, right? So I got to say this angle right here is 72. It's inscribed. That means I know, I don't know why that got so dark right there. I know this arc right here. So what I can do is double 72. 72 times 2 is 144. So I know that this blue arc right here, let me try to erase the angle. That blue arc right there is 144, but 80 is already taken, right? So I'm going to do minus 80, and I get 64 degrees. So arc B is 64 degrees. So though I thought I couldn't find it right away, I had to use that 80 to help. Now I can find A. A is the only missing arc. So I know this arc, I know this arc, and I know this arc. A is the only thing missing. So I'm going to do 115 plus 64 plus 80. And then I'm going to take 360 minus that. So I'm going to start by doing, in my calculator, 115 plus 64 plus 80. That gives me 259. So I'm going to do 360 minus 259, which is 101. So now I know that arc A is 101 degrees. If I have all the arcs, I'm going to be able to find all the angles. Okay? So just pick one to do first. I'll do alphabetical order just because. I'm going to find C first. So if I trace C right here, I should use my highlighter. Here's C right here. Its intercepted arc goes from this point to this point. So it's half the measure of that arc. That arc is 115 plus 64, and I have to take half of it. So 115 plus 64 is 179, and then I'm going to divide it by 2 or take half of it, and I get 89.5 degrees. So I know that that angle C that I already erased the C in is 89.5 degrees. All right, I'm going to do D next because I'm going to stick with alphabetical order. So here's D. It goes from here to here. So I'm going to do 101 plus 15. Sorry, plus 115. And since it's an inscribed angle, I'm going to take half of that. 101 plus 115, and then take half of that. And I get 108 degrees. So angle D is 108 degrees. Last but not least, I need angle E. I can use the quadrilateral to find angle E, or I can use the inscribed angle. It doesn't matter. So I can use this, add these two and take half, or I can add these 4 angles and subtract it from 360. Or those 3 angles, sorry. Since it seems like less work to do the inscribed, that's what I'm going to do. I'm going to do 101 plus 80, and then half of that. So 101 plus 80 is 181, divided by 2 or take half of it, and I get 90.5. So the last angle that I was missing is 90.5 degrees. Okay. All right, one last one. Find the measure of as many angles and arcs as you can. Okay. So start wherever you like. Once again, we have lots of angles, lots of arcs. We can find everything. So what I'm going to do is I'm going to go around in a circle. A, B, that's already done. C, D. And I'll do all my angles. E, F, G, H, I. That's all that I see. If there's more, nope, there isn't. Okay, so usually people start by telling me they see a central angle, the 68-degree angle. So D is going to be the easiest thing to find. It's 68 degrees. Okay. All right, now I need something else. Okay. A lot of times what people will say they see next is this diameter right here, and this is a linear pair. So these two have to add up to 180. So I can find I by doing 180 minus 68. 180 minus 68 is 112. So I'm going to put 112 here now. Okay, please make sure you realize that there are no vertical angles. There is no X going through the center. It's like lopsided. What I'm going to get next is H. H is just as easy as the one that was 68 degrees. It's a central angle, so it has the same measure as its arc, which is 104. Now I can get G because there's a linear pair right here. So I'm going to do 180 minus 104, which is 76. So now I know G is 76. Okay. Now if you look at arc C right here, it is made by this central angle. So arc C also has to be 76 because it's the same as the angle that it makes. Okay, so notice on the other one I was writing down all these calculations that I was doing so that you could see what I was getting the answer from. But this one, it's like, it is this. It's 180 minus this so far. Okay, so now I need E, F, and A and B. So I can do any of those next. I'm going to actually do E and F next. Yeah, I'm going to do E and F next. What I want you to notice is that there's a triangle right here. Okay? Now, what's special about that triangle? If you look at it, it's made from 2 radii. And those 2 radii are congruent. They're the same. So this is an isosceles triangle. And in an isosceles triangle, I know these 2 angles are the same, so I can figure out what they are. I'm going to do 180 minus 76, which is 104. And then I have to break that into 2 congruent angles, E and F. So divide it by 2, and I get 52 and 52. So this is 52 degrees, and this is 52 degrees. So both of those are out of the way. All right, now I'm going to get arc A. Okay, so if you look at arc A as part of an intercepted arc. It starts right here, and then if you continue it this way, there's an intercepted arc right there. That's made by a 44-degree angle. So remember, the angle's half the measure of the intercepted arc. So I know this whole arc is double that. Double 44 is 88. So that whole big arc right there in blue is 88. I already took care of 68 of it. So I'm going to subtract 68, and I get 20. So arc A is 20 degrees. All right, last but not least, I need arc B. There's several ways to get arc B. It's the only arc missing in the entire circle, so you can add all of these and subtract it from 360. But another way is that this is a central angle and it's 112, so this arc has to be 112. So what I can do is I can do 112 minus that part that we already know is 20, and I get 92 degrees. So no matter which way you do it, you should get 92 degrees. All right, that's it.